So today's notes are just on graphing inequalities. I don't know why this says numbers because that's not what we're doing. So we're graphing inequalities. So graphing inequalities on a number line. So our objective today, we're going to be able to graph inequalities on a number line. First thing to review here are the symbols associated with inequalities. So we have this less than symbol, greater than. So less than, I remember that it's less than because it sort of looks like an L. So an uppercase L looks like this. The less than symbol is kind of just like a slanted L. And then a greater than symbol is a backwards L. So L for less than. And then if it has a little line underneath it, that means that it's or equal to. So this is less than or equal to. And this is greater than or equal to. So what is an inequality? So an inequality is a mathematical sentence containing one of those symbols that we just talked about. The only one that's different is that. So let me over here write that this means is not equal to. So if you see that symbol, it means it's not equal. So it's just an equal sign with a line through it. So like an equation, an inequality may be true or false or an open sentence. So first of all, this one's true because -4 is less than or equal to -4. It's actually equal than. This is false because -4 is not less than 4. It's equal to. So the difference between these two, this one has the equal sign underneath, so that makes this true, and this one does not. So this is an open sentence because it has a variable in it. So m is less than -4. It's open because there are a lot of different options for what m could be. An inequality that is open may be true or false. A value of the variable that makes the inequality true is called the solution. Inequalities often have an infinite number of solutions. So here's an example. So if we say that x is less than or equal to -3, the solution to that, so the solution set would be all real numbers that are less than or equal to -3. So that could be -4, -5, -6, and so on. So just one more example of a true inequality. So let's say 3 is greater than 1. That's true. Another false one is if I said, let's say 3 is less than 1. That's definitely not true. An example of an open sentence, it's got a variable, so x is greater than 1. The solution to that would be all real numbers greater than 1. All right, so first example, determine whether -7 is a solution to x equals 10, x is less than 10, or x is greater than 10. So we're checking -7. So first let's check if it's a solution to this. So just plug in -7 for x, and that's not true. So no for that one. And now let's check x is less than 10. So plug in -7 there. And that's definitely true. So that is a yes. And then last one, let's check x is greater than 10. So plug in -7. That's not true. So not true. So no. All right, next example, let's graph